This is the problem with black projects. They're completely isolated from the rest of the world, and they're discovering things as if they found them themselves for the first time, while everyone else who may have been doing a lot of work on the subject is left out of the loop. That really people should be brought in from outside to help on this. You know, this is something we're, you know, why keep it secret? We all want to help out to prepare for the next event.
Okay.
Like personally, my standpoint is, from all the work I've done, I can only talk about probabilities, that we are overdue for one, but I don't know when it's going to come. And I can say that within the next 400 years, there's a over 90% chance we're going to have one. Whether it's a small one or a large one, I don't know. So that's the best I can do. Now, I would be saying something entirely different if I had real evidence that there was one, that somebody had actually detected one. And this would have also an EMP, what we call EMP, electromagnetic pulse, associated with it, similar to what a high-altitude nuclear explosion would do in the atmosphere.
Are you that rare thing, a scientist with a conscience? Is that right?
I guess you'd say so, yeah. It's just me, I guess, that my interest is in helping humanity. And I'm interested in the truth and not living in some dream of some belief system that other people are telling you and doesn't fit the data.
This is Bill Ryan and Kerry Cassidy from Project Camelot, and this is Wednesday the 29th of July 2009, and we are in Lagonisi, which is just south of Athens in Greece, and it's our great pleasure to be here because we are here with Dr. Paul Laviolette, who is best described, I believe, as a maverick astrophysicist who has some very important theories that may possibly be of some impact, if I dare use that word, to people on this planet at this time. And we're here to ask Paul to explain the hypothesis of the galactic superwave. And that's the smallest nutshell I can put this into.
So Paul, why don't you introduce yourself and say something about your background?
Well, I grew up in a family of scientists in Schenectady, New York. Both my parents had worked on the Manhattan Project. My father was a nuclear engineer working on nuclear submarines at the time. So I was exposed at an early age to nuclear reactors and nuclear physics. I was sort of a science buff from very early, with hobbies in chemistry, electronics, pyrotechnics. There was the fellow on the street who was launching rockets from his backyard. Almost had a pretty bad accident. It was sort of just a stroke of luck that I didn't get hurt badly. We moved to Greece for a couple of years, and that was quite an experience when I was in high school. I went to Johns Hopkins for my BA in physics. I then did an MBA. Was a constant objector, so I did 2 years. In the middle of my business degree, I took off 2 years to do alternative service. I was working at Harvard doing research on public health, on respiratory protection of workers. Then after finishing at the University of Chicago, my MBA, I went to, did my PhD in system science at Portland State University. And that took quite a few years to go through that. And then I founded the Starburst Foundation upon graduating. And that's still going. It's a research institute.
What is it researching?
Well, I founded it with the purpose of investigating further the superwave phenomenon. And in the event that signs of a superwave were about to be arriving, that we would go into high gear alerting. It's sort of like like when you have the first warning signs of an earthquake, that you start alerting everyone. And we were dealing here with a phenomenon that few people knew about. So I felt obligated to try to do my best to inform people about this new concept.
So did you train and hire people that were able to handle and understand the science behind the superwave?
At one time, we had some volunteers help out when we, for example, were getting ice core samples from Holland to help prepare the chest to bring the ice. But we never really had funding, serious funding, to be able to hire people.
Okay.
Most of the charitable institutions were interested in funding the arts, and they figured science is left to the National Science Foundation and NASA, but they tend to fund very conventional type research that fits exactly with the paradigm.
So what you're saying basically is that you've created this institute, did you call it, or would you call it a think tank, or
I would call it a research institute.
institute? Okay, and in theory, it's there in case you find that the superwave really is on the way. But in a sense, haven't you found that that is true already?
Well, yeah, there is a super wave on the way from the center of the galaxy. It's 23,000 light years travel distance, and I believe there's not one but several on their way towards us. There were other purposes for the foundation. Also was to do further work on a physics that I developed called subquantum kinetics, which has new implications both for technology and for cosmology. In fact, it completely revises the way we regard the world, the universe. Also, I've done some work in psychology area of thought formation, and so that was a third possible area we could investigate. But also alternative energy was a fourth topic. So all of these.
Okay, so you're saying that there is a galactic superwave on the way, and you think there's more than one?
Yes, several.
Several.
Mm-hmm.
Okay, and the reason you think there's more than one is?
Well, you look at the past to understand the future. In this case, you're dealing with a cyclic phenomenon. And we have the ice core record from both Antarctica and Greenland. And people have measured beryllium-10, which is an indicator of cosmic ray intensity on the surface of the Earth. So it sort of gives you a chart of how cosmic ray intensity has varied over the last few 100,000 years. And going back, you see these peaks. I had predicted you would find peaks when I did my PhD dissertation on this topic at Portland State University. And later the data came out, and indeed there were peaks. And you can take this and analyze it to look for the periods. You find there's certain periods that sort of come out of this data. And one of them is around 26 to 28,000 years, which is approximating the precessional cycle of the Earth. And in fact, the two tend to match up in a certain way, which is very interesting. Another is around 11,500 years. And the third one, there's one around 5,700 years, which is close to the Mayan calendar cycle. And you see that there was a major event at the end of the Ice Age between 11,000 and 16,000 years ago, and that we're in fact overdue now for another one. There were smaller events. You see a small event around 5,300 years ago. It lasted maybe 20 years or so. And there's also very small events averaging every 500 years or so since then. There were 14 small puffs of gas that were emitted from the galactic center, which indicate it was active. But it wasn't active enough to create a peak that you could see in the record.
So you determined this by looking at the ice cores and the amount of debris in them, am I wrong?
Well, they were analyzing beryllium-10, which is a radioactive element. It's produced in the atmosphere by cosmic rays. It doesn't originate on Earth because being radioactive, it eventually dissipates, decays away. It has a half-life longer than carbon-14, so they can go back further than with carbon-14 with this.
Okay, so when you say there's a small event, what is a small event comprised of? How does that affect the Earth?
The small event that happened 5,300 years ago, that was just a little spike, and was easily missed. It was only seen because this particular researcher did a very detailed study of the core, and they found it. Without remarking what it was, I was the one that called attention to it. At the same time, another researcher found the climate cooled inexplicably at that time and became dry. In fact, in the Andes, they found Lonnie Thompson, glaciologist who I worked with at the time I was doing my PhD research. He was the one who sent me samples from the Camp Century ice core that I had analyzed. His team found actual vegetation frozen in the ice, sort of like flash frozen, still had a green color, you know, as if there was some hailstorm at that time. It's the same year they found the Iceman. They're dating the Iceman in the Alps. It dates to about the same time. So it seems like there was sudden blizzards that occurred about that time.
So are you extrapolating that this super wave could cause an ice age?
In this case, the small event didn't cause an ice age, but did cause cooling. But in a larger event, we see these events occurring at the time of the initiation of the last ice age. You see them lining up not only with the beginning of the ice age, but also with the ending, and with major climatic transitions in between. So there's a definite connection between climate and the superwaves.
Okay.
I want to ask some questions here. Because,
sure.
Paul, on behalf of a lot of intelligent listeners we have, who are alert to your name and to the fact that you have been saying some things that are considered by many intelligent people to be important, but they still don't know what a superwave is. And I wonder if you can back right up and tell our viewers, what is a superwave, and do they exist, or is it just a hypothesized event, and why should they care?
Superwave consists of cosmic ray electrons, gamma rays, X-rays, light, radio waves, across the whole spectrum, along with a gravity wave. And this is all traveling at the speed of light towards our solar system. In fact, it propagates throughout the whole galaxy, sort of like a spherical shell traveling out from the center of the galaxy.
So, in simplistic terms, it's an enormous cosmic scale galactic explosion coming from the center of the galaxy.
Right. We've all heard of gamma ray bursts. And
yes.
In fact, some scientists have theorized that the gamma rays are accompanied by charged particles coming along with them, that it's actually charged particles that generate the gamma rays on the way. And this is what a superwave is, except on a much larger scale. Instead of a burst just of a fraction of a second, we're dealing with something that could continue for hundreds, even thousands of years.
When you say it could continue for hundreds of thousands of years, are you talking about it could travel for hundreds of thousands of years and take that long to get here? Or are you talking about its actual impact on Earth lasting for hundreds of thousands of years?
The actual period that the Earth would be going through this storm, you can think of it as a galactic storm,
Okay.
could be anywhere from a few hundred years to thousands of years, like 4,000 years, maybe 5,000 years.
So are you seeing traces that in the past, because you said every 26,000 years, that there's evidence of this, and it matches with the precession of the equinox, are you saying that during that time there's evidence that it stayed around, its impact was that lasted for up to 4,000 years, or at those times did it last for shorter periods?
Well, if you look at the record, in my book I show the beryllium-10 record. You see, for example, around 40,000 years ago, there was quite a hefty peak there, lasting 5,000 years, the whole thing. And this is actually one event that there's been a lot of study on by other glaciologists, and they all agree that the cosmic ray intensity went up in a real fashion at that time. Although they've proposed an alternative theory of supernova explosion, without saying where is the supernova. You know, they suggested a star nearby exploded. My answer to that is this happens very rarely. To have a star explode that close to cause the cosmic ray intensity to significantly increase on Earth, and we're talking about many peaks. You know, they were sort of just wanted to explain the one, but what about, I mean, there's in the record that we have, there's something like 12 to 15 peaks.
And these are cyclical, so in essence, stars don't explode on a cyclical basis.
That's
as
the
far
other
as we
thing,
know.
yeah.
Okay. Go ahead,
Can I
Bill.
ask you, Paul, is there a hypothesized, a recognized hypothesized mechanism whereby whatever it is at the center of the galaxy, and most astrophysicists think it's a black hole, would actually emit these superwaves on a cyclical basis? Is there some theoretical background for the existence of that periodicity?
I haven't heard them put forth something to explain the cyclic nature. I think that they find it sort of mysterious. The conventional view, because they see this going on in other galaxies, they're called exploding galaxies or ciphered galaxies, quasars. These are various names for the same sort of thing. At one time they thought a quasar was an unusual object in space, when in fact it turns out it's a galaxy whose center has become so bright that it looks star-like, and they don't see the galaxy itself. But with the Space Telescope they found the arms there. They would think that these exploding galaxies have a cycle on the order of several 100 million years, and that the period of the explosion would last about a few million years, with the idea that if it happened in our own galaxy, because they also would say, well, it's possible it would happen in our galaxy too, but they say, well, we're in the quiescent period now, which should hold for at least another 50 million years, so we shouldn't be worrying about it. And even if it did, the conventional view is that these cosmic rays would be held back by the magnetic fields. These would come to our rescue to hold back the cosmic rays from leaving the center of the galaxy.
So to get back to your theory, though, of what you call the superwave, you see evidence that we are in the midst of a superwave now, or several of them, you're saying?
No, they haven't arrived. We're in the eye of the hurricane, sort of the period, the nice sunny period in between the storm, before the storm arrives. And the thing is that you can't see them coming because they travel at the speed of light. So it's a phenomenon, it's totally without warning, just like a gamma ray burst. They only know it when their detectors pick it up, and then they're able to locate where it came from.
Well, if it's coming to our solar system, wouldn't other planets be affected before we would?
Yes, it affects all planets, all stars
So
in
in
the
a
galaxy.
sense, you could see it coming if you saw the effects on other planets before it hit Earth. Is that right?
Well, the light from those effects on the other planets also travels the speed of light.
Oh.
So it actually lags behind the actual event itself.
Yeah, this is something, I mean, I understand very well that this is something that you can't see happening because of the nature of the limit of the speed of light, and this is something that travels at the speed of light. So basically this comes up and hits you from behind, as it were, and you've got no warning.
There would be only one way I could see that you could have warning. If, let's say, a hypothesis, there were civilizations in the galaxy, there was intelligent life, that recognized the importance of knowing when these were coming and set up outposts at different points that were able to relay a signal that was superluminal, in other words, travel faster than the speed of light, to get the warning here so we know exactly when the next one was going to arrive. That's possible.
Okay, well, we actually have a witness, Jake Simpson, we call him Jake Simpson, who has said that they did send a superluminal craft outside this solar system, and that they have seen a wave approaching. He called it a wave. We're not sure if he actually meant a wave, but in essence, they saw something headed toward us.
And who is they?
The people that he works for in Black Projects, basically. So this is Jake Simpson. So that was one of the reasons that we were sort of interested in hearing your theory, because in many ways it seemed to coincide with what he was saying they saw.
And how close is it, did he say?
In this period of years between now and 2017.
Yes, it was very interesting. It was a conversation which I personally had with him last October when we met. He's not a physicist. He's an intelligent man. He's worked for Black Projects on the inside, and he's saying things to us that are at the limit of what he can say. What he said was that there is a wave coming, and he stressed that the wave was a sort of loose term, as a metaphor. He said to think of it in terms of a wave. He said like that. I have no idea whether he's acquainted with your theories.
Well, this is the problem with Black Projects. They're completely isolated from the rest of the world, and they discovering things as if they found them themselves for the first time, while everyone else who may have been doing a lot of work on this subject is left out of the loop. And the only people that lose out are the human race, basically, because here's I've been working on superwaves since 1979, so what, 30 years, and I would be happy to work with them you know, I believe I'd have something to contribute if they did have some information like that.
Sure.
Be able to
So,
interpret
well,
what
I
they're
mean,
saying.
actually, is it possible that they are following your work, benefiting from
I'm sure
it,
they bought my
etc.?
book, and it's circulated among the Black Project scientists.
Especially if your parents, as you said, worked in the Manhattan Project. They're
Regardless of that,
okay.
I think they're searching for new ideas all the time to sort of funnel this into what they're doing. I think to some extent they realize that they don't have all the ideas, that there's interesting stuff out there. But I think it's that really people should be brought in from outside to help on this. You know, this is something we're, you know, why keep it secret? We all want to help out to prepare for the next event.
Okay.
Like personally, my standpoint is, from all the work I've done, I can only talk about probabilities, that we are overdue for one. But I don't know when it's going to come, because I'm looking at the past record, I see the cycles, I see when the last events occurred, and I can say that within the next 400 years, there's a over 90% chance we're going to have one. Whether it's a small one or a large one, I don't know. So that's the best I can do. Now, I would be saying something entirely different if I had real evidence that there was one, that somebody had actually detected one. Well, Starburst Foundation, for example, would go into high gear to say, you know, we've got to start preparing. We're not prepared for something like this. Not even for a Carrington event solar flare, which could wipe out all the power systems if we had one.
So are you saying that the superwave would result in the wiping out of the power systems?
Oh, yeah.
What other effects would it have?
The thing is, the superwave on its forefront would have a very dense sort of shock front of cosmic rays. And this would have also an EMP, what we call EMP, electromagnetic pulse, associated with it, similar to what a high-altitude nuclear explosion would do in the atmosphere. And when this arrives, it's going to create similar phenomena. just like the starfish explosion. I believe it was near Hawaii, and when the EMP wave arrived, there were whole sections of the island who were having blackouts as a result. It also would fry electronic circuits, phones would go out. We've had even smaller events like gamma ray bursts affect the communication systems and do damage to our communication systems. So something like this would pretty much roast all the satellite equipment we've got. Cell telephones wouldn't be working. TV would be off the air if it depended on satellite. Perhaps telephones would continue to work if it was fiber optic. It was insulated from this sort of thing. Your power lines would pick up the pulse. The wires would have a huge voltage surge, which would fry the transformers, the step-down transformers, to go from your million-volt voltages down to your voltages you use in your house.
Wouldn't it always also affect the cars that we have now?
The cars that are all now with chips in them, in a case of a EMP from a nuclear explosion, for example, they warn that it could fry the chips in a car.
And this is something that could last 400 years, you're saying? Once it
Well,
arrived.
the forefront, we're talking about something that might just be minutes.
Okay.
And it would be probably preceded by a gravity wave, which would cause earthquakes, seismic events all over the Earth,
Okay.
not just in one place. So that might be the first warning, actually, things shaking.
Let me back up just a fraction again to help our viewers understand this and also to help me understand this. Does a superwave incorporate a gamma ray burst, or are these two different phenomena that you're
They're a
describing?
little different. The gamma ray bursts they talk about are usually from isolated stellar explosions, perhaps very, very powerful supernova explosions. And they have some special physics involved there that the stars are very unusual, like neutron stars colliding and so on. The thing is that whatever they are, we can only guess because they're so far away. Most of the gamma ray bursts that we are picking up come from other galaxies, millions of light years away.
Yes.
There's been only one case. We've observed one that came from within our galaxy. It was a place near the galactic center, but not at the core. And what's unusual there is that about 2 days before the gamma ray burst arrived was the worst seismic event that we've had in 30 years that caused the 2004 Boxer Day tsunami in Malaysia. And over 250,000 people who died in that event.
So you're saying that was caused by a gamma ray explosion?
Gamma ray burst. This was the first one they'd found that was emitted from within our galaxy. It was the most intense that they'd ever observed in the history of gamma ray observatory physics. And the coincidence of being just shortly after the worst earthquake we've had in 40 years, it's you can do the probabilities, and you come with very small probabilities due to chance.
So you're saying this gamma ray versus a super wave, if you were to compare them as events, would you say that the super wave is, it sounds like it's much more long range, much more, it would impact for years at a time,
Yeah.
and it's cyclical as opposed to the gamma ray bursts that maybe aren't explainable?
The gamma ray burst, probably the source star ends up blowing itself up completely into smithereens, so there's no cycle involved. Whereas core explosions, we're dealing with the massive object at the center of the galaxy. Scientists call it a black hole. I don't believe in black holes, and I know other astrophysicists that don't believe in black holes. But I do believe it's a very massive object. It's a core, I believe it's a core of a star. In a natural evolution, a star will eject its atmosphere and you're left with a very dense core that has a density similar to a white dwarf star, which is like, let's say, 1 ton per cubic centimeter, or in extreme case, go to the density of a neutron star, which is a million times greater. I mean, we're talking about a spiral galaxy whose core object has evolved to the point where it's starting this outburst cycle. And by the way, that's how a galaxy is formed. These outbursts actually participate in the formation of the galaxy. That's what causes this spiral phenomenon, because without these outbursts, the spiral arms would wind up on themselves. This is a problem which astrophysicists have wondered about. Why don't the spiral arms wind up as it turns? Well, it's because you have these periodic outbursts coming out, and they sort of propel everything.
But do you know what causes that? The periodic
yeah, I have a theory. It comes out of subquantum kinetics, and in subquantum kinetics, you have a continuous creation of matter and energy. Basically, a violation of the first law of thermodynamics, which is no big deal. You know, maybe physicists would consider it a big deal. But the point is that we're talking about a level that's 10 orders of magnitude smaller than what they can observe in the laboratory. And in fact, I have suggested an experiment where they can observe it in space with microwave signals between spacecraft. And I've published the amount of the energy increase of a photon over that period of distance. And in fact, they ended up finding this, and it's today called the pioneer effect.
Okay, so this subquantum kinetic, what do you call particles? It's a theory.
Subquantum kinetics is the name I gave to the physics. It's resulting from taking concepts in system theory, the area I was studying for my PhD work. If you bring systems concepts into physics, and bring, for example, models that have been developed in the area of chemistry, of how chemical waves form, and I realized that these, for example, form a very good model for describing how a particle forms in space. And you find that it solves a lot of problems which physics had before. Physics traditionally has been based on mechanics, and we're talking about a chemical approach, a chemical reaction approach to physics. Actually, you could say it's alchemical, and there's an ancient, it ties in with ancient ideas too.
Does this relate to hyperdimensional physics and particles being waves, depending on how you look at them?
Okay, it does postulate existence of higher dimensions. The basic idea, which is what steered me into all of this work that I've been doing, was the realization that the basis of existence is flux. This is totally different from what physicists have been teaching. Physicists teach that the basis of existence is structure. There are particles that are somehow bound to each other. Even quarks, they speak of quarks and gluons, glue that holds them together, so to speak. If they began talking about flux, from their point of view, because see, physics is positivist science, they want to observe, to actually say, well, there it is, I observe it. Where is this flux? Well, they can't see it, and you can't see this flux because it's at an etheric level. You postulate an ether as the substrate forming physical phenomena.
A gamma wave, gamma ray burst, basically is a local event that comes from a supernova, and which is hugely destructive and powerful, and we're quite fortunate not to have any near us. And we've basically mainly seen them, if I understand it right, in neighbouring galaxies. But the superwave is something different, which is cyclical, is accompanied by a gravity wave, is accompanied by cosmic ray debris, and lasts quite a long time, like a storm, and leaves its imprints and its echoes materially in ice core samples, which is tangible evidence that you have that there's something going on here that's not being recognised. Can you speak to all of that and lay this out simply for people so that they can sort of see the territory we're talking about here?
We also have supernova explosions in our own galaxy, but they're not of the kind of the very powerful that cause these gamma ray bursts. Unless, when we're seeing these gamma ray bursts, what it is just a clump of very energetic particles that happen to come our way at that moment. And when scientists are saying it was very, very powerful, they're saying, imagine that this was the same energy from whatever angle you viewed this star. And it would end up totaling to a huge astronomical amount of energy. But if it was just a clump of a burst, a collimated burst that happened to come, then you're down to more reasonable levels. So and the thing is, we don't really know. You know, these things are so far away. But we do know that the supernova explosions that have happened within our galaxy don't really affect us that much unless it happens to be one very close, like within 30 light years, which is a very rare event. But the core explosions are different in that instead of just a fraction of a second for the event, you're talking about anything from several years for a very minor event to 4,000, 5,000 years duration. And the longer events can actually start affecting climate because what they do is they vaporize cometary ice which is surrounding our solar system and end up pushing this nebular material into the solar system, and it affects the way light gets to the Earth from the sun. It ends up energizing the sun. It falls onto the sun. The sun becomes more active and more of a flaring star. And actually, the sun ends up then doing more damage to Earth than the superwave itself. The superwave is sort of what gets this dust in, and then you get worse things happening.
So is it possible that solar cycle 24 could be acting on the Earth as a result of a superwave that's
No.
going to hit the sun? No.
No, because we're in the in-between period, in between superwaves. The solar system is fairly clean of dust. I mean, if the solar system was packed with dust like the level I'm talking about, we would all see it. You would see the moon being blotted out by a dust cloud, or the sun, huge dust cloud going across the sun. I mean, it would be definitely coast-to-coast news. So we're at both sides of the planet.
These dust clouds, aren't they also traveling at the speed of light from the galactic core?
No, the dust doesn't come from the core of the galaxy. It's already around our solar system, and it's pretty much stationary, relatively stationary, just orbiting the sun normally. But when the superwave arrives, it creates a sort of a shock front around the solar system, because the solar system has magnetic fields around it, and it creates what they call bow shock around the heliopause. Heliopause is the name of the sort of protective sheath of magnetic fields around the solar system. And in the magnetic fields, the superwave particles tend to get trapped to some extent and build up to very high levels, enough density of cosmic ray energy to actually start vaporizing ice. And when that happens, so it's actually able to raise the temperature from close to, let's say, 10 degrees above absolute zero up to the level where the ice could vaporize and release both dust and water vapor or gas into space, and this stuff gets pushed in as it's being pushed in by the superwave cosmic rays, because it's like a battle between the solar wind and the superwave cosmic rays. Solar wind is sort of expelling this dust, but then the superwave is pushing this in, and it will actually compress the magnetic field sheath that's around the solar system inward. And it could, in my thesis, which I published in 1983 on galactic core explosions and their effect on the Earth and solar system, I was suggesting that the sheath at the end of the Ice Age actually got pushed in almost to Mars orbit. And so from there, it's just a short hop for this dust then to come in around the sun, and it would actually produce a cocoon around the sun so that the sun wouldn't be yellow like we see it. It would actually be reddish.
So let me feed back to you what I think that you're saying. What you're saying is that the superwave creates a huge energetic impact on the dynamic systems in the solar system, and then that causes so many energetic complications, and I'm speaking very generally here deliberately, that's actually what creates the major changes in weather that could last for several thousands of years, because the reverberations electromagnetically and in the dust clouds and the behavior of the sun and everything else are going to cause quite a long ripple effect locally after this superwave itself is actually all over. Have I got approximately?
Yeah, think of this as in systems concepts. Think of a system, and they speak of perturbing the system with an outside influence, a force or something.
Yeah.
The solar system, and in fact the Earth's climatic system, is here being perturbed by conditions that normally don't exist today.
Right.
The whole energetics around the Earth changes, and if it's in place for decades and decades, that's long enough for the Earth's climatic system to get perturbed into, let's say, an ice age, or to come out of an ice age.
But
If it was very brief, it wouldn't be long enough to cause this huge climatic shift that we've seen.
But you are saying that you've observed that this is cyclical, and you've observed that this happens every 26,000 years. And if you're pulling in, from what I understand in your book, you're pulling in, astrology, the tarot, the Mayan calendar, and all these sort of prophecies that, how the Hopi say there are different ages that we go through. In a sense, you must be predicting one coming fairly soon,
Right,
according to the cycle.
Yeah, well, I found cycles of 28,000, 11,500, and 5,700 years. This was done by some people in the state of Washington who did some number crunching as a sort of contribution to Starburst. We do have people that help out at times. And with that, we could see that we're overdue presently. But before they had done this to get more of a scientific, accurate estimation of the cycles, you could see my own work I did just by eyeballing it, and could see that there was this both 13,000, 26,000 year period there, but I was a little off perhaps. In the short one, it's more close to 11,500, and then there's the 5,700 year period.
So if it arrives faster than the speed of light, then...
not faster. I'm suggesting at the speed of light, although the gravity wave would have been slightly superluminal at the very beginning. If it was due to an explosive outburst, that would have caused it to get a slight head start. But pretty much the whole thing travels at the speed of light towards this.
So then it could happen at any time. Am I right?
Yeah, we're in the
if it
danger
happened-
period. We're sort of like, you have to realize, which a lot of scientists don't because their theories still believe that galactic core explosions are every 100 million years, but you have to realize that we're on the fringe of a volcano, galactic volcano. And it's an active volcano, and we should be expecting the eruption very shortly.
When you say very shortly, because I understand you're looking very long range, what's very shortly? Is that in a year, 2 years, 4 years, 100 years?
I don't know. I only go out on the limb and I say there's a 90% chance in the next 400 years of this happening. I think I'm pretty safe that something will happen, even if it's a small outburst, because astronomy, we've been around really, modern astronomy, for a few hundred years now. We haven't seen any bright luminosities come from galactic center.
What about the fact that we're coming equal with the galactic center? Does that affect any of this, or make it more likely, or the way it hits us change?
No, that's what you're talking about, the Mayan calendar and the sun crossing the galactic plane. There's no effect there. It's more you have to look at the period and when the last event happened. And it's interesting that the 5,300-year event, the small event of 20-year duration or so, occurred just before the beginning of the Mayan calendar cycle, the one that we're currently in. That cycle began 5,126 years before 2000, or before 2012, so around 3,100 BC. Whereas we're seeing this event was around 3,300 BC, plus or minus a few hundred years, because we don't know accurately from the dating. We're relying on ice core dating, and it could be a little off. Maybe it's off by 100 years or so.
What I want to achieve here is some way of assisting many people who watch our videos to understand the scientific basis for which it's plausible that something might be coming this way that is in our interest to understand and possibly even to prepare for. That people are picking up intuitively, they're reading things on the internet, things get distorted and muddied around and they don't know what they're reading. And they hear these terms like superwave and gamma ray burst, and they don't know what they mean, and they don't know whether this is mumbo jumbo, whether it's really something that could affect their lives and change their lives, and they don't know what basis there is for taking these things seriously and digging more into it. And the reason why we're here talking to you is because you're the man who represents and is the spokesperson for these important ideas. And I say they're important ideas because any hypothesis in physics is an important idea. Even if it's disproved, it was an important idea until it's disproved, and this takes the whole thing forward, as you'll understand. So the opportunity here is for you to explain to the listeners, to the watchers, to the viewers, as best as you can, how it is that these phenomena should be taken seriously in your recommendation. What impact they might have on us, what are the probabilities, is this catastrophism that we should be ignoring and say, what, everything's going to be fine, because it's always been fine, or maybe the geological record shows that things have not always been fine, and we should be on the alert because we're living in an unstable planet in a very dynamic system that's affected by all kinds of things which we're only on the verge of starting to understand.
Well, what you're saying is the same questions that went through my mind. Is this a real phenomenon? And that's what caused me to change the topic of my dissertation, my PhD work, to investigate the superwave phenomenon. In 1979, when I first discovered that this might occur, I formed a hypothesis. I called it the galactic explosion hypothesis, and convinced my dissertation committee that I could do this to test this hypothesis. And that I could produce a PhD on this, which I couldn't have done at a lot of universities. It happened I was in a program that was very interdisciplinary. So the idea of bringing evidence from various areas, from geology, astronomy, paleontology, high-energy physics, was fitting with this program. And in the end, I summarized the evidence and found that it all seemed to support this concept that a superwave had indeed passed through our solar system between 11,000 and 16,000 years ago, causing major effects to the climate. And we had a very significant mass extinction, that's called the Pleistocene extinction, where large mammals died along with species of birds and a number of other animals. And some people have said it's the worst extinction to have occurred since the extinction of the dinosaurs. And I was also drawing from ancient legends, although I didn't include that in the dissertation, but I do believe that that's a valuable source of information.
All the flood myths, for example?
Flood myths, the story of the sun burning the earth, Scorpio being stung by, Orus being stung by the scorpion. Scorpion is a sign in the direction of the galactic center. Things like this.
This is where the tail of the scorpion in the astrological symbol actually points towards the galactic center.
Right.
As if the ancients are trying to tell us something.
Yeah, there's two arrows in the astrological symbols. Now, remember that the signs, what we call the astrological signs, are actual constellations out there, and this is how they were originally formed as star constellations, that there are two arrows in the zodiac. One is the Sagittarius arrow, and the other is the tail of the scorpion, and they're both pointing, it seems, at something. And this was my first connection I made between astrology and the galactic core explosion phenomenon, when I realized that the center of the galaxy was in that region where they were pointing.
So what you were positing there was the ancient astrologers, who are also astronomers, were actually trying to leave a message for us in such a way that it would get lost over time.
Right. I believe that the zodiac was a cryptogram, a time capsule message that was created to warn the future civilization on our planet about this.
So that's where your intellectual journey started, but presumably you couldn't start off with a PhD thesis.
Right. I didn't include any of that. I mean, who cares really where you got your idea? The point is you make a hypothesis and you're testing it. Is there scientific evidence for it? And this is the main thing from the scientific standpoint that you're concerned with.
But what you say is that there is no pole shift, that you don't see evidence of actual, and maybe you can explain this to me, but my understanding is you say that there weren't pole shifts at those 26,000 year periods, but there was instead this galactic superwave explosion.
Or even 13,000 or 12,000 year cycles. Right. That I believe that the climatic shifts that people have, other, I don't know if you want to call them scientists, theoreticians, have suggested that the pole shift was involved in creating a climatic change. That, first of all, there's so many shifts of climate, just even during the Younger Dryas, which was between 11,600 and 13,000 years ago, you see something like 40 major shifts of climate within that cold period. And to say that was due to shifting back and forth of the pole gets to be a little absurd.
Okay. What's your response to the good work, or no, let me say, to the serious work of Charles Hapgood and Rand Flemath and more lately Colin Wilson, who's been popularizing the idea? I mean, we tend to call it pole shifts, but they're talking about crustal displacement. I understand that you don't feel that the crustal displacement theory is valid, and it'd be very, very interesting to hear why that is.
You know, if the evidence supported, I would be for it. But, you know, you just go to the ice core evidence to test that theory. For example, Mr. Flemath was talking about Antarctica being sort of up closer to where Chile is during the Ice Age, and it had suddenly shifted down to its present position at the end of the Ice Age. Okay, if that was true, then you would expect the climate in Antarctica should have been warmer during the Ice Age, and you don't see that. And I sent him something like 4 climatic curves from Antarctica, which showed it was colder during the Ice Age, and from different parts of Antarctica. It didn't seem to sway him, I guess, but from me, looking at that data, that rules out a shifting of the poles.
So, any kind of crustal,
Plus, it would have caused sloshing of the oceans, you would expect, if there was such a thing. And then how come we don't find saltwater deposits inland? We do find flood deposits, but it's due to fresh water, which I've suggested is due to the melting of the ice sheets, catastrophic melting.
Could catastrophic melting of the ice sheets explain the Great Flood?
Yes,
The myths?
yeah.
That much water?
Yeah, it's something that doesn't happen today because we don't have ice sheets. We do have sort of ice caps like in Iceland. We have situations where the glacier there is melted in a certain area by a volcano and creates a sort of a reservoir of water which eventually bursts through a dam and pours down, and they call this a glacier burst.
I'm with you, yeah.
These are very small scale compared to what was happening during the Ice Age.
So, in order for there to have been a great flood like the one described in the myths, the ice sheet would have had to have been much larger and sea level lower than it is at the moment, and then there would have had to be a catastrophic melting. And your theory is that that could only have been produced by some huge cosmic scale event, which you are calling the superwave. Is
It was
right?
mainly the sun involved. The superwave triggered the conditions for the sun becoming more active,
Okay.
and also the cosmic dust around the Earth actually creates, in some cases, a warming effect because it can actually scatter light that normally go out into space back onto the Earth, creates sort of an interplanetary hothouse effect.
Okay.
And this was something not only going on the Earth, but also we see evidence on Mars of canyons appear to have been cut by tremendous floods of water.
Yes.
And I believe that Mars is mostly covered by ice sheet. It's sort of like a tundra. And the actual walls of the canyons are actually ice that would have melted during some of these events. Especially there's cases where the Earth was being hit by super-sized coronal mass ejections. We have evidence from the moon of glazed rocks, and one NASA scientist was suggesting that the moon was exposed to very intense radiation from the sun to do this, something like 100 times greater luminosity of the sun for at least 100 seconds. And in my dissertation, I suggested the alternative that perhaps both the Earth and Moon had gotten engulfed in a coronal mass ejection, and that this was hot enough to actually melt particles on the Moon.
Does your theory accommodate the loss of water on Mars as a result of a superwave action upon the sun, or?
Can you say more about the loss of water on Mars?
Well, my understanding is that Mars used to have water, and maybe even plentiful water, and that at some point it disappeared, and there are different theories to explain that disappearance.
No, Mars is about 2 kilometers deep in ice.
Right now, you
It's
mean?
covered with an ice sheet from pole to pole. You might find some areas where it's more rock, but for the most part it's ice. Why does it look like dust, like a dusty surface? It's because on Mars, when the sun shines on this icy surface, the ice sublimates, turns directly to gas, and leaves the dust behind. And so for the first few centimeters is just dust. But below that is what we would call permafrost.
Has this been validated by the rover the Mars rover?
Yeah, they
Taking
had a
samples?
rover thing going around just a year ago or two.
Right.
They had pictures they sent back, and sure enough, there were chunks of white, which was really ice, mixed in with the dirt. And the reason they know that it was ice, they took a picture a little while later when the sun had a chance to shine on it, and it had disappeared, evaporated. So this stuff is just below the surface. In fact, they see gullies which look like freshly formed by running water. So in some cases, this ice melts as long as it's underground. There's enough pressure to make it turn into water, and it can actually gush out from the sides of some of these canyons and create these ravines.
That's pretty interesting. Okay.
And I was saying this about Mars being covered with permafrost way back, and as more and more data has come out with the satellites, they've been doing radar sensing, and they find that it's several kilometer or so deep with water there. It's not pure water, it's mixed with dust and stuff.
I wasn't aware of that.
So going to Mars, there's no question that we will find water. I mean, wherever you land, all you have to do is get something to melt whatever you dig up, you know.
Okay, let me take you back to the events of 11, 12,000 years ago, whatever. One of the events on the legitimate historical record, according to Plato, the sinking of Atlantis, round about the same time as these mass extinctions of all the large mammals and so on and so forth. Is it possible that a superwave would be accompanied by the kind of gravity wave that I believe in your thinking? It doesn't cause a crustal displacement, but I think your words are, it jerks the planet to such a degree that it can cause a serious impact.
Yes.
Resulting in earthquakes. And
Yeah, you don't need to really have a huge displacement of the pole to cause major seismic disturbance on the planet.
What about a magnetic pole shift? Is this related at all?
I believe the magnetic pole shifts are due to the sun's effect on the Earth. And what happens there, I describe it in my thesis and articles. When a coronal mass ejection arrives, the cosmic ray, the solar cosmic ray particles get trapped in the Earth's magnetic field. And they produce what are called storm time radiation belts around the Earth. And the particles end up drifting, the electrons in one direction, the protons in the other, and this generates what they call a ring current. This is all accepted geophysics, and produces a magnetic field opposed to the Earth's field. And they observed this after the 1956 solar proton event, when a coronal mass ejection, a fairly large one, had hit the Earth, and they observed a 1% decrease of the magnetic field at that time. And so all you have to do is scale that up 100 times, and there were in fact events that were that large around the time of the extinction of the mammoths and ground sloths. And you do see carbon-14 spurts. This is something I'm about to publish. This is very new. I've actually located in the ice core the event when that solar cosmic ray burst hit the planet. And that would have been enough particle energy to actually cancel out the Earth's magnetic field.
So you're saying that the sinking of Atlantis was resulted from that?
No. I have a totally different view of the Atlantis story. I believe it's an allegorical story. I don't believe, and I've argued with people who are Atlantis enthusiasts, they believe they're going to go out and find an island with moats and dikes around it. Now, that's the part in Critias. The Atlantis myth is broken into two parts, one in Plato's book of Critias and one in Plato's book of Timaeus. The Critias myth is the creation of Atlantis, and the Timaeus myth is about the flood, which, if you date the time it's given in Plato's myth, it comes to about 11,600 years ago, when in fact there was a very accelerated period of glacial melting, that the sea level was rising very rapidly at that time. And so you were having flooding. And I believe that in the Timaeus myth, Atlantis is symbolizing the ice sheet. The sinking signifies the ice sheet was melting. As you remember in the myth, it's talking about Atlantis leaving behind a shoal of mud. Well, when ice melts and the floods subside, that's what you have, a shoal of mud. So in effect, Atlantis, the ice sheet, the North American ice sheet, which is almost like a continent, they speak of it as a continent, dissipated and is now in the waters, in the ocean. In fact, in the myth, in Plato's book, this is a discussion between Solon, the ruler of Athens, and a priest in Egypt, and at Sais in Egypt. And the priest tells him that this is these myths, like the story of Atlantis or the conflagration myth about Phaethon and the sun chariot, where the sun ended up burning the earth, that these are allegorical stories. They're not, these things didn't really happen the way the myths describe. You have to infer that this is a parable. Look at it allegorically. And that, for example, he referred to the story of Phaethon, that this really represents astronomical bodies in their effect on the earth. In fact, in this case, the sun.
So what about they say that the magnetic poles are shifting now. Do you agree with that?
By how much are they saying?
Well, I'm not sure. Bill, can you explain? I think there is, like, they've actually said there was a noticeable shift recently.
Yeah, I don't have the numbers. My understanding is that it's recognized that there is that there looks to be a gradual shift happening because of a weakness. There seems to be a gradual shift happening. I don't have the numbers. If that may mean that it's hard for us to talk about, but I thought that that was recognized. Maybe I'm wrong.
Well, the intensity of the magnetic field has changed over time. It's varied up and down by about 50% during this last interglacial, last 11,000 years. In fact, it's been weakening since year 2,000 years ago.
Okay.
So, that's a trend which probably could be continuing. I haven't looked at the same data you're talking about.
Okay, so to get back to the galactic superwave and its impact on Earth and when it could occur, what are you using predictive sort of referencing certain things like the tarot, like astrology, like the I Ching, etc., to predict the coming of the superwave?
No.
Okay, so what are you using?
It's all based on science, and something we didn't get to is what is the evidence for the past event. I really didn't get into that.
Okay.
I made a series of predictions, and one was if, and this was the key test that I performed, but there were others, was that if this had actually occurred, it would have pushed cosmic dust into the solar system, and we should therefore see higher levels at that time. So I did a study of ice core samples. I was sent some by Lonnie Thompson, and I also got some ice directly from the ice core laboratory and processed it myself, and used neutron activation analysis, which is a technique where you irradiate the dust that you filter out from the ice, you irradiate it in a nuclear reactor and it becomes radioactive, and you see what's in it. And I was looking particularly for nickel and iridium, which, for example, iridium is 10,000 times more abundant in cosmic material than it is in the typical crustal material. And, in fact, found peaks where the iridium level, for example, was hundreds of times higher than what we normally get today. So it indicated something was really happening. This was a discovery that was as significant as the discovery of the iridium peak at the Cretaceous tertiary boundary. Now, the difference there is you had a Nobel laureate in the team, along with 3 others who were members of the Berkeley faculty. I was with a moderately known university, Portland State, but I was not in a astronomy program or geology program. I was in the systems program. So this was passed over at the time. It was cited by some astronomers in the UK, Victor Klube, for his own theory, actually before my results were published, which ticked me off a little, saying that a comet had hit the Earth around 14,000 years ago. As it turned out, my dating was off at that time, and when I finally, because ice cores weren't properly dated in those days. This is in the early 80s. And when I finally found the proper dating of the ice samples I dated. Turned out they were between 35,000, 70,000 years old. So I was looking at a period in the early to middle ice age rather than the part I really wanted to test. And actually the ice was missing from the ice record from that period because it had already been sampled. That was the most interesting area that researchers wanted to look at, was at the end of the ice age. And so even if I wanted to, I couldn't have studied that part.
Well, how do you account for that?
Why is the ice missing? Because other researchers sampled that very heavily and all the ice got gobbled up. I came late in the game, so to speak. Those cores had been around for at least 5 years before I started my tests.
But what you're saying is, in essence, that you did prove the fact that there was this an escalation in the amount of iridium, as you call it.
Well, it was the first time elevated amounts of cosmic dust have been found in the ice record. In fact, one of the samples I found high levels of gold, which would have been, if it was a mineable deposit, you could have made a lot of money in that section.
When was this?
That was around 50,000 years back.
Okay,
It's a
because, well, I'm not sure this is related at all, but my understanding, I don't know if you go back to the days of the Anunnaki when they supposed, Zecharia Sitchin's work and the fact that they were mining gold to put into the atmosphere of their own planet to protect, from the sun's rays and so on, the loss of atmosphere. Is there any correlation there between your finding a lot of gold in the samples that you were getting 50,000 years ago?
Well, gold is a also enhanced material in cosmic dust. You find several hundred to 1,000 times more gold in meteorites and cosmic dust than you do on typical Earth crust material. So the Earth, I believe, was being exposed to increased amounts of gold dust. In fact, gold nuggets could come from space. You have myths, stories of gold meteor, where they find a nugget. And in fact, this gold tends to be concentrated at the bottom of gravel deposits. Whenever there's a flood, the heavy stuff's going to deposit first. And so whatever was coming down ended up getting concentrated by these floods in certain layers. But anyway, that was one victory for the hypothesis. Also, I was noticing that the certain supernova explosions, in fact, this was part of what tipped me off about the superwave phenomenon, that it wasn't just an explosion at the center of the galaxy, but something came out and was actually triggering supernova explosions as it moved out from the center.
Oh, okay. So it's actually affecting stars.
It affects stars, yeah. Stars that are near ready to explode, there might be on the unstable part of their history, end up exploding. And for example, the Vela supernova remnant occurred at the time when this superwave was moving through our area. The Vela is the closest supernova remnant to the solar system that's of the young remnants. And then the Crab Nebula, which was 6,000 light years further away, so it occurred later, and it's documented in the Chinese records at 1054 AD, July 4th, turns out. That went off and it was seen, and you have to figure it takes time for the light to come to us, so it's like 6,500 light years away in the direction opposite to the galactic center. So you have to allow about 6,500 years for the superwave to get out there. Then it triggers this, and there's another 6,500 or so years. So that's why we saw it more recently. And when I plotted the new supernova remnants, I found that they tend to line up on this event horizon, as I call it. It's actually an ellipsoidal horizon when you plot it out with the Earth at one focus and the galactic center at the other. And the reason for that, why isn't it a sphere? Because if you think of this, actually the super wave travels out as a sphere, a shell. But because for us, we have to allow for time for the radiation to reach us. So if these cosmic ray electrons are generating radio waves at some star system, you have to allow time for that radiation to reach us. And what you see is that there's a shell of radiation out there that we are inside of, that's being generated by these superwave cosmic rays as they go out and they interact with magnetic fields and so on. And when you plot that on a graph, that model fits like a glove to the what's called the cosmic background radiation, which is acknowledged that it's produced by cosmic rays, but scientists didn't really have a good explanation of why it's there. You know, they were suggesting, well, maybe there's supernova explosions that go out and contribute. The superwave model prediction fit better than anything that had been published before.
Is that the same background radiation that most cosmologists believe is evidence for the Big Bang?
No, that's the microwave background you're talking about. This is the galactic radio background.
Okay.
And more recently they found there's also a galactic gamma ray background, which is diffuse emission, and they can't explain why is it diffuse. They would expect if it was due to stars, you should see clumps here and there of gamma rays. Instead, it's very diffuse. And again, I believe that's due to the shell of cosmic rays going out. So the thing is that most of the energy from the superwave ends up being directed outward from the galactic center. So once it passes you, you don't see it very easily. It's only this radiation that we're seeing, that astronomers report, is only when the cosmic rays end up getting caught in a magnetic field and they turn their searchlights towards us. In other words, they're beaming that energy, that radio emission, outward in the direction they're traveling. But if they get caught and turn around, we'll see some of that. But that's a small fraction of those cosmic rays. So we are very aware when it's happening. When it arrives suddenly, we're going to see a bluish white star in the sky, similar to what the Hopis talk about. And we'll see a lot of activity of sort of aurora-like things around the heliopause, that shell around the solar system. We'll see activity in our own, auroral activity in our own magnetic field.
What about the effects on DNA? Have you posited any possible effects on?
Well, if you figure the levels we're talking about, because you can't postulate two great cosmic ray intensities, because otherwise, if that was the case, the surface of the Earth would be radioactive, like you have huge carbon-14 levels. In fact, that was a restriction that I had to put into my model. And looking at the levels that are reasonable, you would have had a slight increase of mutation rate, maybe a doubling or tripling mutation rate at that time. However, it's not really the superwave cosmic rays that are of most concern. It's the ones from the sun. Because once the sun, this is only in the case of very long-lasting superwaves where the dust has come in and surrounded the sun long enough to aggravate it into what we call a T Tauri star, because we see stars similar to our sun that are in dust cocoons that are very active and spewing out coronal mass ejections and solar flares, super solar flares. So once the sun goes into that phase and one of these very large events like extinction level events hits the Earth, then not only you're dealing with major mutational change, but also possible death if you happen to be caught outside when this happens. And it's interesting, geologists have found a connection between extinctions and magnetic reversals. And they couldn't really understand why is there this connection, because if the Earth's field went to zero, you'll get maybe a doubling of the cosmic ray background on the Earth. So that wouldn't be enough to cause an extinction. Maybe it would accelerate a little the mutation rate. But if both were due to a coronal mass ejection from the sun, it was an extinction level event, that would explain it. So they're both due to a third cause in that case. They're not directly causally related.
Now, it sounds very compelling, certainly to the degree that we can talk with you about this on a non-scientific level, as it were. But what measure of support and interest have you had from the mainstream scientific community?
I've been, for example, to the Galaxy and Solar System conference, and there was also the Lunar and Planetary Science Conference in Houston, where I gave a poster paper. I stood in front of a board where I had the whole thing laid out and explained to people who would come up, and did talk with some fairly high-level cosmic ray astronomer or astrophysicist who found the whole idea very plausible. So I haven't had anyone publish a paper against the theory. No, I was hoping somebody would, because I would have nailed their ears to the wall. I feel the evidence is so strong to support it. Basically, in general, why aren't they all coming on the bandwagon? Well, it's a major change of the paradigm. The paradigm is that everything is calm out there. We don't have anything to worry about. You don't want to get into catastrophism because that makes you emotional. Emotion shouldn't be in science. We shouldn't be scared when we do science. I don't know. I don't really get scared by this. I just am studying the past. You know, it's something, you know, you are concerned. It's something we should know about our future. But science has traditionally stayed away from these areas, anything dealing with catastrophism. If you look at all the flack that the group from Berkeley got when they made the discovery about the dinosaurs being hit with a comet or asteroid, they were attacked by many people, many geologists, who felt we should only do geology based on what's happening in the earth, volcanoes, this sort of thing. So, and that was something 65 million years ago. Now you can imagine what I'm talking about just 13,000 years ago, or 16,000. It's within the realm of the human race. And so it becomes, people are more fearful to join. And they're wondering, well, if I write in support of his theory, what's the consequences for me? But I have had my paper cited that I published. I published in referee journals, in several well-known, in monthly notices, in Astrophysics and Space Science, to name a few. EOS, which is more of a scientific newsletter.
Aren't you dealing with also, I mean, this galactic superwave, you're also dealing with this kinetic physics.
Subquantum kinetics?
Subquantum kinetics as being part of this galactic superwave theory in some way, form, or fashion. I mean, you're actually talking about, if you're talking about quantum physics, you're also talking about what is the ether made of, such that the galactic superwave will impact or impact in how it impacts space and how it impacts.
Well, ether is a controversial topic, which
Right.
indeed subquantum kinetics is an ether theory. But you don't have to bring that in for this superwave phenomenon. The superwave phenomenon can be based totally in the current view of physics, pretty much.
I understand that. But I'm interested, because you obviously are thinking about both things, that there must be some kind of place where they link up in your own mind.
Well, it
in
was really
theory.
my work in subquantum kinetics that brought me to the discovery of the superwave phenomenon.
And
And
how,
that's
can you
through a
explain
long
that?
path.
Well, I mean, can you explain that in you know, sort of easy terms to understand at all?
Well, I had been developing subquantum kinetics for many years. I'd basically written up the early papers, which I was at the point ready to submit. I had already submitted to a few journals. And at the same time, in the meanwhile, I was studying ancient lore because back in 1975, had discovered that the tarot encodes concepts very similar to what I was talking about in the physics. And I did take a class in Cambridge, Massachusetts, on the tarot. And as the teacher was going each arcanum, now the tarot is a set of 22 cards that are used in fortune telling, but they date back to the Middle Ages from the Gypsies. The earliest decks are attributed to the Gypsies, which had migrated from India through Egypt, and esoteric scholars believe that they had picked up the concepts from the Egyptian priests and prior to the collapse of the priesthood. In the very early days, the kingdoms of Egypt, the priests were in power. They had an indoctrination into this ancient science that explained how the universe was created. And that these concepts that were at that time, there were frescoes on the wall of the chamber that the new priests were brought in and taught the meanings, that these were later put into the tarot deck. Anyway,
so can you trace one of those particular scientific concepts as depicted in the tarot and how that relates to kinetic
subquantum
kinetics?
Well, subquantum kinetics is based on process. It's the idea of, it's an alchemical ether, basically. It's an ether that's not static like the 19th century ether that physics grew out of, but one more like closer to Heraclitus' concept. This is an ancient Greek philosopher who said that all is process. Closest
Isn't that like
is to think of the
all is motion? Aren't you talking about everything
that's
being
close
motion?
to the idea, but here it's more a reaction. There is motion in terms of just like you have in a chemical solution, you have molecules diffusing from one place to other place, but they're also reacting. So basically it's the same understanding you have for how your own body works. So how is it that the structure of our body is made from the reactions and diffusions of chemicals? And so this is a very organic concept. It's more like close to the organic ideas of Star Wars, of the Force, and they're very close. The galaxies bound together, the universe being bound together by a fabric, organic fabric. It's sort of like every part of space, this ether, is affecting every other part of space.
Okay, and if I called it energy, would that be the same thing?
I don't use energy because I save that for electromagnetic waves. It's energy-like, but you can't speak of energy at the subquantum level.
Oh, I see.
It's there's a prime mover, something that moves this reaction forward. It's unidirectional. It's sort of like the direction of time in the big sense, capital T, moving forward.
And since we have a secret witness that also talks about he's tapping into what he calls the information field, and when we said, is that the same as the consciousness field, he would say no, because he thinks the consciousness field is individual based, whereas this thing he's calling the information field would encompass everything.
Mm-hmm.
Is there any kind of way you could have a dialogue about what, because this gets to signal non-locality, for example, if you're familiar with that.
My view is that to explain what's here, we have to postulate higher dimensions and a flux of ether that we cannot directly measure, but only hypothesize. And the way you know it's there are experiments that you can do that shows that there is an absolute reference frame, that relativity is wrong. I give many experiments in my book. In fact, the geopositioning system that the military uses is based on the idea that light goes faster in the direction of the Earth's rotation than the opposite direction. And if they didn't accept that, which is anti-relativistic, they would not locate people, their forces on the Earth. They would maybe bomb the wrong embassy.
Okay, so if you could explain in terms of, I don't know if you can do this, but in terms of your subatomic model, how can you explain that to us on the basis of an experiment?
Well, there's what's called chemical waves. Scientists were, at the time I was getting the idea for subquantum kinetics, they just published work on the Belousov-Zhabotinsky reaction, which is a chemical reaction where you put some dyes in there that change from red to blue depending on the state of the reaction. And there's a molecule, cerium, which can go between two valence states. And as the reaction churns forward, cerium in one given place in space oscillates. They call it chemical clock. So if you stir this up with a little stir, your reaction will change from red to blue on regular, just like a clock. And they call it the chemical clock. But if you leave it unstirred and calm, it will form little wave patterns, sort of like a bullseye pattern with, let's say, a blue center and a red ring and then a blue ring and so on. In effect, like
Meaning a spiral.
Only, no, actual concentric rings, like Atlantis. Remember Atlantis? In fact, in my book, In Genesis of the Cosmos, I suggest that the Atlantis myth is actually, they're describing a subatomic particle based on this new physics. Now, understand that my theory came out of systems theory. It was only later I saw the connection with the ancient science that was being discussed symbolically. But getting back to the reaction, this would be red and blue waves. They become spiral waves. In fact, they were on the cover of this magazine, spiral waves, because they look, they're more artistically appealing, so that's why they concentrated about spiral waves. But that happens only when you give a little mechanical disturbance to so that the rings reconnect to form a spiral.
Uh-huh. So, okay, so how does this...
Well, how does this relate? Well, I thought, well, this is an interesting model for subatomic particles. I was reading Einstein's treatise in Scientific American. He was talking about his difficulty in unifying electromagnetism and gravitation. And in there, it talked about his view that there were no such things as singularities, which would mean Einstein himself would be against the black hole theory. And his reason was it would disrupt the space-time fabric, which he believed should be continuous. And he believed particles were bunched, places of bunched energy, so to speak. And I was saying, well, here, this is looking like a bunching here, you know, where you have a core with this wave pattern around you. So the core is really a high concentration of a certain element. And I was saying, instead of working with molecules like you do in chemistry, let's come up with a new name, etherons. I initially called it sub-physical units, but later I said, what the heck, go all the way. Let's use, let's forget about the taboos. And the ether is an ancient concept, and people weren't afraid of using it. And if you look at the real experimental evidence and stop regarding science as a religion, you know, it is very religious in some ways, in the sense that existing physicists religiously believe in their theories, and to the point of ignoring the evidence against them. But so you can imagine this soup of etherons of different types, A, B, C, D, and so on, reacting according to a certain recipe. And what I did was come up with a set of reactions which I believe were physically realistic. In other words, they created physically realistic particles that produced electric and gravitational fields just like regular matter that would obey the classical laws of electrostatics and gravitation, that would bind, have nuclear bonding, and it made certain also have spin characteristics, and it made certain predictions, astronomical predictions, one being that light waves, that their energy should not be constant, but they should, over great distances of going through intergalactic space, they should lose energy. In other words, redshift.
Do they?
They do, and that's what's called the cosmological redshift. And whereas scientists have interpreted the cosmological redshift as an actual velocity effect due to a recession of a galaxy. In other words, if the galaxy moves away, it would cause this effect, which is very mechanical, mechanistic interpretation. They didn't, well, the tired light theory, as it's called, the idea that light waves lose energy as they travel, was proposed about the same time as this other theory. But the thing was, they didn't have a reason for it to occur. You know, it was another way to interpret it. The more mechanistic was more easily grasped, and so they went with that. And that's why we have the expanding universe theory today. I wrote a paper for the Astrophysical Journal in 1986, which is the top journal in astrophysics. It's the same one that Hubble published in. The astronomer they attribute the expanding universe to, and showed that if you look at the data and compare the expanding universe model to the stationary universe model with tired light effect instead of motional effect, you find that the tired light model always comes closer to your data. And I did it on 4 tests. And the reason I did it on 4 tests is that when you adjust your model, because Big Bang theorists are adjusting their model to fit the data because it never fits the data. So if they want to adjust their model, that's fine with me, but they have to be consistent in what are its effects on these other tests. And you find that their model ends up getting pushed further from the data as soon as they try to adjust it here. And that's why they'll always publish on 1 test and not on 4 simultaneously.
Okay, so how does your theory, you're talking about tired light, how does this relate to your theory of kinetic sub?
Okay, well that's one of the predictions that came out of subquantum kinetics. That was a testable prediction, and I went ahead and tested it by looking at the data to see did it support it, or was the Big Bang theory correct? Because at that time I was just like everyone else believing in the Big Bang theory. But I wanted to give this a chance, and, you know, slowly I realized, my God, you know, subquantum kinetics is right, and all this other stuff is baloney that they've been teaching.
So what happens? Okay, the light, tired light means the light, you're talking about energy dissipating, right?
It
or
actually,
changing form.
In subquantum kinetics, the energy actually leaves the physical universe, in a sense that the wave just diminishes in amplitude. Energy is not a constant in subquantum kinetics. Why? Because subquantum kinetics proposes that the physical universe behaves like an open system. What is an open system? It's like we are an open system, biological organism. We must eat, we have input and output. We must breathe, we take in oxygen, give out carbon dioxide. If those processes cease, we die. And the same with the chemical reaction model, the chemical waves. You only see the waves as long as the chemical reactions are taking place. As soon as they use up the food chemicals and they go to equilibrium, the waves disappear, dematerialize, and so to speak. So the same for this physics. The physical universe would dematerialize if this flux, which we should all be thankful for, in my opinion, were to ever diminish or cease.
Well, then, between dimensions, I mean, I don't know if this is related, but in theory, between dimensions, then, that's exactly what must happen. In order to dematerialize and move between dimensions, that energy has to dissipate to or come down to 0 so that you can move to the next. Because if it dematerializes, it goes into another dimension.
Okay, you're talking about a physical being, like a human being,
maybe
wanting to, you're talking about the soul?
Well, actually I'm talking about, well, I mean, what I'm thinking about is the ability for even ghosts or ETs to go through walls. And I mean, and now we're actually seeing movies in which, you know, the powers that be have created, and I don't know how do they do it, but they create techniques by which you can change the composition of a wall such that you can go through it.
Yes, I believe this is something that's possible.
Because if this model works on the subatomic level that you're talking about, it has to.
Subquantum.
Okay, well then it has to work all the way up, right? To the fact that you get to the larger particles.
With subquantum kinetics, you can explain dematerialization and rematerialization. This is something that's easily done.
Okay.
And it involves a change of the gravity potential. if you were to increase the gravity potential enough, an object would dematerialize. Or at first it would become invisible, which means if you look at a...
Change the gravity such that it becomes heavier or lighter?
It would be lighter.
Okay.
Like the sun is in a gravity well. The sun is in a very materialized state. If we were to go out into space, way far from the galaxy, because the galaxy itself is in a gravity well, we would go into the area where I was saying photons lose energy, this tired light effect. Everything there would tend towards a homogeneous state, would tend to dematerialize. If the opposite effect is within the galaxy, instead of having light losing energy, it gains energy here. It's the opposite. And you have blue shifting of light. And in fact, I made a prediction. I called up JPL in 1980. I said, have you seen anything with your signals to your spacecraft, microwave signals? Maybe slight blue shifting of the signal. So, well, no, we haven't really looked for such a thing. Say, well, keep an eye open, see what you see, because if so, it would support my theory. So around about 7 years later or so, 8 years later, they start noticing, oh, by the way, I published this in 1985 as a test of my theory, that if you did a test sending a microwave signal from Earth to Jupiter, to a spacecraft in Jupiter, and relayed it back, you would find the energy was slightly higher. And I said, how much? Because my theory would predict what that amount of increase would be. Well, about 7 or 8 years later, they start noticing something's a little peculiar in our data. It's becoming blue shifted. It's as if there's a force pushing the spacecraft towards the sun. And they finally published this in 1998, and it became known as the Pioneer effect. And then they published further information 4 years later. Now, there have been thousands, literally thousands of papers written by physicists about the Pioneer effect, trying to explain it, what it is. There's only one paper published before it was discovered that predicted it, and that was in my publication of subquantum kinetics. And it was published in the 1985 in the International Journal of General Systems.
So did JPL come find you when you were proven correct?
I sent a copy of my book marked where I made the prediction, because the paper actually took a picture of the original journal and marked where it was stated, and also sent a copy of my book, which further explained, to the head man on that publication team at JPL. Basically was ignored. He didn't even send me a preprint of his paper that I requested. So all I had was the news announcement. He never told me, well, it's going to be published in this journal on this page. No, he never told me that. And I was never mentioned 4 years later in the follow-up paper. So, my experience is the average physicist or NASA scientist or astronomer is a cowboy. He's interested in his own theories, not in yours. If he confirmed yours, he's not interested. That's the way it works.
Yeah, it's worked on that.
Okay, but the implications of what you discovered could point to the reality of other dimensions, as you say, dematerialization. You may be on the road to explaining how other dimensions could exist.
Right. Subquantum kinetics is a unified field theory. It explains all of the forces that unified field theories deal with. And it fits together like a Swiss watch. Relativity effects come out of it as corollaries. You don't have to postulate ad hoc like Einstein was saying. And there are now 12 predictions that were previously published that said things entirely different from what physicists were saying that were later verified by observation. So these are like confirming certain things that has predicted were confirmed, and I don't know of any thing that's said so far that's been disproven. So it gives you a lot of encouragement to believe that we got something here, plus the fact, looking at general relativity, it had only 3 predictions that were confirmed. Now we're dealing here with 12. Plus, you find that ancient civilizations had this physics. They went to a lot of trouble to encode it in some of the most important creation myths that historians have written about. And even it's encoded in the zodiac. And even though the zodiac is used for horoscopes, one of the main technologies used in field propulsion, this exotic propulsion that's developed in black projects. In fact, the B-2 bomber I've discussed in my recent book, Secrets of Anti-Gravity Propulsion. I explain how the B-2 bomber uses Brown's research and patents, basically. It's based on his ideas. So with subquantum kinetics, it's not just explaining Brown's work, but a whole host of other technologies too, like John Searle's technology, Eugene Podklenov's gravity impulse beam, in which he's able to produce gravity impulses from electric shock discharges, which are the gravity impulses collimated, can go for kilometers and kilometers, staying together, and he's found it actually travels superluminally. So this could be the centerpiece of a superluminal propulsion engine. From what I've seen actual demonstrations of superluminal shock propagation in the laboratory, Guy Obolansky's work. And with this technology of Podklenov's, I would say it's possible to do superluminal space travel, which completely changes our outlook of interstellar communication and interaction with other beings, that it's possible that they could actually travel here. Another thing that comes out of subquantum kinetics is it completely changes what we think is possible for energy. And you find these technologies where they're getting energy out of water, like John Eccles' patent that they're developing in the UK, and they say they'll have a hot water heater out in the next year and a half or so, or Randall Mills' invention produced by Blacklight Power Company. He's got something like 20 of these prototypes being tested that he believes will produce 50 kilowatts of power for your average house. That these are explained by subquantum kinetics, because subquantum kinetics leads to a revision of quantum mechanics. There's a flaw in quantum mechanics. Even though quantum mechanics is workable, the model is incorrect. The wave packet model is incorrectly formulated. And when you go to the subquantum kinetics version, you get the same results. It explains experiments with the same mathematics, essentially, but it allows the possibility for ground states in the hydrogen atom that are more levels of energy in the hydrogen atom. It allows the hydrogen electron to jump down and release energy that we thought wouldn't be there. And that's what these various scientists have tapped into with their inventions. So subquantum kinetics leads to the development of a lot of new energy sources that would be considered alternative energy.
Okay, so go ahead.
It's hard to understand why other quantum physicists haven't picked up your work with a lot of enthusiasm. What's your explanation for this? Is it
it's too no.
Is it because it's too big a scope, or it's too radical?
It's too big a shift. New theories are picked up if you're not changing the basic structure, basic paradigm. If it's a new idea within the existing paradigm, it will be very quickly picked up if it's going to explain things better. I'm talking about basically wiping the slate clean as far as theories go. Most theories, most modern theories, you can keep some of the classic equations, Newton's equations and so on. But
Maxwell's
Well, Maxwell's no. I mean, it even revises that. You have to look at Maxwell's equations as a model of a phenomenon. It explains electromagnetic wave propagation in a different way. And for one thing, Maxwell's equations, at least the accepted version, have energy being conserved. It means that energy of a photon can either increase or decrease. Whereas here, as we were saying earlier, over great distances, you will see a change. There are a set of principles which are considered sacred in physics. One is the first law of thermodynamics, this idea that energy cannot be changed, only converted.
And you're changing that law, really, are you
Right.
not?
And I can show technologies which you can perform in your backyard garage which show a violation of energy conservation. Some of these electrostatic thrusters, like Jean-Louis Naudin has on his website some Laforgue thrusters. They're basically asymmetrical capacitors that he's got in a pinwheel arrangement. And when you calculate how much energy he's putting in to drive that pinwheel, it's a lot less than the motion he's getting out of it. He's getting out about 3 times more motional energy than the electric.
It has to be an open system. Go back to what you were saying before.
The universe. Yeah.
Sure.
As soon as you view the universe as an open system, you have to realize that energy is not necessarily conserved. Pretty much all system theorists will agree with you. If your physics is postulating an open system for the universe, then you do have the possibility of matter or energy increasing or decreasing in amount in the physical universe. The thing is that this is like just a small shadow on the sort of an epiphenomenon of this vast flux that's going on below the level of observation. So that's where your real energy is. Not energy, it's action. So in other words, just for this table and this stool or chair to be there requires an enormous expenditure of action, subquantum flux, which is totally invisible to us, and we only infer that it's there through a series of conceptual models and understandings.
Are you able to theoretically predict the physics behind an over-unity engine as a result of this? Can you predict how to design one before you start tinkering in your garage about this?
Well, yeah, it could lead to some predictions of that sort, but in the way it's generally worked with me is I've read about people's work in this area and find that I can explain what they're finding with subquantum kinetics.
Okay, yeah. But,
So-
I mean, sorry, perhaps I didn't form my question in the right way. What I really meant was, from your theoretical understanding, could you predict which engineering approaches are more likely to be successful?
Yeah, I think so, yeah. I think that with this physics, you can explain a lot of the technologies they're developing in the black projects for field propulsion.
Yeah.
And I wouldn't be surprised if a lot of my readers are in the black projects. I would have no way of knowing. But
Yeah, that's what I was thinking.
I mean, they were actually working on ether theories in the 50s to explain electrogravitics. Townsend Brown was developing an ether theory. They were working on one at Douglas Aircraft, which apparently they ditched, and it eventually was declassified somehow with some notes. Maybe it was just some notes that somebody had that were supposed to be classified, but they were leaked out. And from conversations I've had with some Black Projects engineers who acknowledge that to them the ether is real, that they realize the faults of relativity that when they recruit, they prefer that the people they're recruiting haven't had their minds polluted with current physics. They try to get them at an early age.
That's exactly what we've heard. Yes, they pick up
Yeah.
very, very, very bright kids and
Absolutely.
sweep them off.
And it's actually to the advantage of keeping the secrecy that they would see it's good for them to keep teaching baloney in the universities that they realize is wrong, because what they're doing is impossible in that frame of mind.
Yeah.
And it's very difficult for people to get out of that. It's sort of like asking the goldfish to discharge its tank of water. It's not going to want to do that very easily.
Yeah, oh, for sure. But it must be immensely personally frustrating for you to consider that to consider the possibility that your work may well not only be correct but be taken to levels which you would love to be in on, and yet you're locked out of this because maybe they consider that they don't need you, they understand it already. I mean, that's the kind of expediency that they would...
I'd actually been asked to participate in one project that was being formed, gotten off the ground, but I saw that it was going to be secret, even though they were intending it to eventually be open, but you never really can be sure what will be the result.
So why did you stand back from that? What was your motivation?
I guess there's the risk of being locked in on the wrong side of the door.
Yeah. You know, when you start working in secrecy, you feel a little stifled.
Well, are you that rare thing, a scientist with a conscience? Is that why?
I guess you'd say so, yeah.
And is that a result of your parents' influence, would you say, to some degree, or
Oh, yeah,
something
yeah.
else?
I would say that's part of it. Just you know, just me, I guess that my interest is in helping humanity, and I'm interested in the truth, and not living in some dream of some belief system that other people are telling you and doesn't fit the data.
Also, the elite, in other words, the elitism around using technology or using the truth only for a certain group of people, perhaps is going against the grain.
Yeah, the thing is, who is controlling the black projects? As soon as they're black, I mean, they're not even acknowledged by Congress or whatever government has them. Somebody's pulling the strings. And there's some people that suggest they aren't even from Earth. You know, if you believe that.
Now, can we get back to, I mean, you did say that you had some kind of contact experience that affected you. Are you able to describe that in some detail to us?
Well, it was basically an inner experience I had when I was at Johns Hopkins in my junior year. And I felt there was information coming into me. I was in a certain mental state. I felt there were intelligences from the plant kingdom. I felt they were terrestrial, that the trees were talking to me, the vegetation kingdom of Earth that was concerned about the way we were going. They were concerned also about being wiped out by the progress of human society. It's like we're out of control here with growth. Sort of like the movie Koyaanisqatsi, that whole concept. And at the same time, they were giving me the basic understanding that the basis of existence is flux. Because if you have flux, you can always produce structure. In other words, if the flux goes in a loop, now you have something that exists over time, because it's the same and the same. Whereas if you start with structure, structure itself doesn't imply flux, because you're dealing with something that's static. Why should it move? It's not. It's static. So that's the beauty of flux. And that shifted my whole perspective, and I started on this quest of understanding nature, developing my own system theory before I knew there was such a thing as system theory. And that eventually led into development of physics, this subquantum kinetics, which I developed while I was studying business, actually, at University of Chicago. It was a course on organization theory. We were asked to write a term paper, and I had the course was studying general system theory and viewing businesses as open systems. And it was in this experience where I started melding the idea of open systems with Einstein's article that I had read and chemical waves and so on, and suddenly had this epiphany. And the paper that didn't end up being on business. The professor who has behavioral psychological background ended up giving it to a friend of his who had a physics background to evaluate.
And the rest, as they say, is history. No, I mean, because that sounds like it propelled you to the direction you've gone on.
Yeah, I remember I had a sort of what you'd call a Kundalini experience during that, where I was awake all night writing, and then I'd sleep during the day and get up at late afternoon and be walking around in the mall, the university, the grass area between the buildings, and would look at a tree and I could see this energy flux in the tree, or the stone looked like it was alive, sort of like with the view of the shaman Indians. Because it completely shifts your perspective when you go to this. It's more close to the Hindu idea of Maya, that Maya is illusion, the physical is an illusion. It's just we're waves on this. The real essence is the ether, which is non-material.
Is that connected with David Bohm's implicate order?
It's close, but the concepts are, excuse me.
So, again.
The concepts of subquantum kinetics are similar in some respects to David Bohm's theory, but David Bohm's working in general relativity, relativistic framework, which he hasn't completely wiped the slate clean there. I accept some of his concepts, like his idea of stochastic fluctuations as a representation of zero-point energy. That this is not just the idea of probabilism in quantum mechanics is not just some equation you're writing, but it has a real basis in something, some medium having stochastic behavior there. In this case, I would say it's the ether. But I use different terms. I speak of the implicit order and explicit order. The implicit order is the etheric order. It's ordered in the sense of the reaction pathways that are very defined. And the explicit order is the wave order that we see, that we're able to see. We need waves to see other waves. You know, everything is waves. So that's the quantum realm. The subquantum is the implicit order, and the quantum is the explicit order. And the explicit order evolves out of the implicit order. The reason why we have a particle that's a wave pattern, subatomic particle, the reason that exists is because you have this cyclical yin-yang sort of reaction going on at the subquantum level. Yeah. Yeah. So just then a manifestation of what's already there, just emerges.
Mm-hmm.
Yes.
It leads to a continuous creation, cosmology.
Sure.
So that matter is being continuously created even this moment.
Yes.
It's not something that happened all at once like the Big Bang Theory says. It's going on, especially at the highest rate at the center of the galaxy, but also within stars and planets.
Well, what about the idea that it's going on outside of the galaxy in other, like there's a theory of Ananda Bosman talking about what he calls the great magnetic attractor, that there's other, and he said, you're saying within the galaxy there's a black hole or whatever. It's not a black hole, but you're saying this.
Mother star, I call it.
Okay.
Very old star. It's the oldest star in the galaxy.
So beyond this, because there's lots of galaxies, right? So do you go beyond that?
Yeah, every galaxy is creating matter and energy. And if that continues, these galaxies will grow and grow. They'll spawn other galaxies because they'll eject star clusters. You know, every time the core explodes, it ejects star clusters. That's what populates the halo of the galaxy. Some of these, if they're very large ejections, will actually be small galactic nuclei that will end up spawning another galaxy. Think of the large and small Magellanic Clouds that are very close. They could have been ejections from our own galactic core, or maybe they just happen to nucleate close by. But you do see some that look like they came out from the core of a mother galaxy. And Halton Arp, an astronomer, talks about this, that some of these look like as if they were ejections from active cores. But eventually, you could say an extreme, maybe the whole universe become filled with matter and energy. It's very possible before it would even get to that point that the set point that's causing all this creation would change. Something that might have a period of several 100 trillion years, like in the Hindu view. The Hindu mythology talks about Vishnu waking up every so many 100 trillion years. And everything dematerializes. All of the Maya is withdrawn, and everyone realizes all along we were Vishnu. We were this essence. So,
but is it possible there could be then another eruption?
Yeah, it's the idea that not only we have cycles in terms of core explosions, but also the whole universe goes through a cycle of creation and dissolution.
So you never found the standard Big Bang theory?
Well, it's interesting that they had it right in one way. There are Big Bangs, but they're at the centers of galaxies. There wasn't a single Big Bang creating everything. And interestingly, these Big Bangs are associated with creation because the creation rate is the highest in the mother star, as I call it, in the core of the galaxy. And that really goes out of control. It's like a nuclear reactor going supercritical, where it ends up going into a very active state, expelling all this matter and energy that had been created for thousands of years, is now expelled. And as this is moved away out from the core, then the gravity potential field that was gradually getting deeper and deeper around the core now comes up a bit, and it cools off. The reaction cools off, because like I was saying, in subquantum kinetics, this whole creation process is tied to the level of gravity potential. So that's why there's a cycle involved. So creation's always going on, but then it gets really extreme and goes through this outburst, and then things subside. It's almost like with a volcano that releases the pressure that's built up underneath, and then goes into a quiescent period.
Going back to Maxwell and electrogravitics, have you spoken with Tom Beardon?
We met. We were talking more about his free energy device, which I don't know if he's actually got it working at this point. Actually, there's some concepts that are similar. Beardon has some similar thinking in some areas to subquantum kinetics.
Okay.
But we haven't really discussed it.
Sure.
Okay, but rather than drill down there, because we need to wrap this up, is there a way we could kind of pull in some of these threads into something that would kind of make sense in terms of where you might be going now with your work and why?
Well, like right now I'm writing a paper on the mass extinction at the end of the Ice Age, which I believe was due to a solar cause, coronal mass ejection striking the Earth. I'm hoping that by advancing in various areas, it's sort of like a front that you're pushing in various places. Like before I was writing more on this subquantum kinetics. Now it's more close to climatology and catastrophism. In the hopes that some advance will get people very excited. I'm hoping this will get them excited and attract more attention to what I've been saying.
Well, what about the idea of, are you thinking that you might be getting close to some kind of model of consciousness itself?
I have done work on that too, is the feeling tone theory model that I developed in the 80s based on Bill Gray's work, who's a system psychologist, psychiatrist, and melded his idea that thought is really based on feeling tones. It's really feelings when you get down to it, and was able to explain how those feeling tones emerge into a thought using concepts which are similar to what I used to develop subquantum kinetics. It's really, a system theorist can go at a very abstract level and bring stuff from one field into another, which is what I did there. And that theory also, it matched very closely with a lot of neurophysiological data, a wide spectrum. It was sort of like hitting the target 11 times. And we did some consulting to use aircraft, which used that as their way of enhancing creativity. And I was later told that they saved $40 million using this approach. That was, if you put some price on the increase of creativity that resulted.
Mm-hmm. Yeah, I mean,
I think it's safe to talk about that since their Hughes aircraft isn't around anymore.
In theory.
It's all been broken up. And
yeah.
It would be nice to be rewarded with a few percent of that added value.
yeah, I mean, Starburst could do a lot more in contacting the scientific community and attending conferences if we had our coffers full.
I read, for instance, that there's some just routine scientific work that is expensive but accepted. Like, for instance, mass spectrographic analysis of ice core samples that will really do a lot to bolster your theories, and it just hasn't been done because it's so expensive and you're working on your own, is it?
Yeah, in fact, this theory of the mammoths and mammals being wiped out by coronal mass ejection, which it wasn't just one, but there was a series over several thousand-year period, but there was one real major one that sort of ended it. That you can test that. You know, I've located the place in the ice core. All we need to do then is sample for beryllium-10, and see did beryllium-10 spike up at that time. Look also at carbon-14 in sediment cores. And these are things that can be done to test the theory. So I'm hoping once I get this published, I can convince some others, some colleagues, that we team up and do this.
Right, because that's simple stuff. I mean, scientifically speaking, that's simple stuff. Yeah.
Okay, well, let's say that maybe this interview will kind of go towards that direction of attracting people to you that could make these things possible for more investigation in all of these areas that you're working in. But I want to thank you very much for taking the time to explain this to us in a way that we could understand it, which I think you did well. And hopefully we can learn more about your theories and also the applications of those and see what kind of pans out in the future.
And we do know that there are some smart people in high places who do watch our videos because they're never quite sure what we're going to come out with. And they watch us quite carefully.
That's right.
And these are not necessarily bad guys. These are smart guys and they're good guys. And it's entirely possible.
Some of them.
Some of them are. And it's entirely possible that if your work hasn't come fully to their attention, it may just give them a little prod to take another good look at what you have to offer here.
Yeah, you know, what you mentioned about, you heard from this fellow who was in touch with a Black Project, or he was a Black Projects engineer, talking about space travel with superluminal spaceship.
Right.
I wouldn't be surprised if part of that is misinformation. I don't think it was our superluminal spaceship he's talking about. It was from an ET civilization. They'd been in touch with ETs who told them this.
Entirely possible. And it may have, I mean, that may be entirely accidental because he may well have been relating that story second or third hand. But the principle was that he said, there's a wave coming. He couldn't describe it exactly. He wasn't a physicist, actually. He was an operative rather than an engineer. He said he thought the time scale was more like 2017, but he did say that superluminal craft had been out, taken a look at it, had reported what was going on, and that he said it could I think his words were something like, it could just be a puff of wind or it could turn the Earth on its axis, but nobody really knows what's going to happen.
Well, I recently deciphered a crop circle, the one that shows the Avalon one that from 2008, shows the solar system, the planets arranged as they would be in 2012.
Right.
I think I remember reading something where you were talking about this. Hey, Pluto's not where it should be.
David Wilcock has uses that in one of his talks.
Yeah.
Obviously in the wrong place.
Right, and because I know one fellow who's believing that this means the superwave will arrive in 2012, and he's actually working with people to build a shelter down in Australia right now, expecting that this will hit 2012. But my reaction is, why would they put that obvious error in there? And so I looked at it and noticed in the diagram that appeared 1 week later that shows what looks like Neptune's orbit, that circle, and it's marked, which seems to represent Pluto's crossing point on Neptune's orbit. And then it's got a little elliptical diagram with little circles, as if dividing it 11 equal parts. And to me, that's an elliptical exaggeration of Pluto's orbit, so that we don't mistake it as a circle, showing 11 subdivisions of Pluto's orbit. And if you take the period of Pluto's orbit and you divide it by 11, you come to the amount that Pluto's displaced in that crop circle.
Okay, yeah.
And if you add that to 2012, you come to 2035 AD with the exact date, June 8th, when that crop circle appeared. In other words, it would have been 27 years into the future from 2008,
Okay.
which is interesting. So what are they saying? Does that mean that's when a superwave will arrive? Will it be the time when the current one will end, that it might arrive 2012, or what? We don't know. But there is something on the pulsar diagram that even before this happened, I had written about it on my website. Somebody had discovered that, having read my book, they wrote me an email, said, by the way, did you know that the periods you attracted our attention to the Crab and Vela pulsars, which are these two supernova remnants, which are very important, close to us, in addition to Vulpecula pulsar, and I had stated the periods for these three, that they sort of form a symbolic arrow, if you understand the pulsar diagram, as I call it. That the periods are very close to the Fibonacci series, which create the golden mean. And sure enough, if you take the ratios of the two longer period ones, they come to the golden mean ratio within that, it's 10 to the minus fifth, the difference. In other words, 100,000th is the deviation from that, being perfect. But you notice that the Crab period is significantly off, and this is assuming if the second is a universal standard in extraterrestrial communication now, because I'm suggesting that the pulsars are an extraterrestrial message, that pulsar is at 33 milliseconds. So if it's really 34 is the number you come up with in the Fibonacci series. So if you say, when would the Crab pulsar have that period where it ends up being 34 milliseconds? Well, it's in the future by so many years, and it comes out not very far from this 2035 date. I was coming up with something like 2037 or so, 2038. So it seems like something's going on here. It's interesting.
Right, so there's some kind of message there, but you're actually deciphering it differently than some of the 2012 enthusiasts, if you will.
Yeah, I think there's not enough information to immediately conclude that they're telling us we will be hit by a superwave on 2012, although a lot of people have contacted me who said, they've been in telepathic contact with ETs who are telling them 2012 a superwave will arrive. In fact, one fellow said he had this ET contact and they were telling him about cosmic ray wave coming, and he wanted to know more information about it, so they said, well, just look up the work of Paul L. So he did a surf with Google and found my work, if this is, I don't know if, you know, if this is true, I mean, maybe they're aware of my website. I don't know. There.
Okay, so that's a great place to end. Okay.
Oh, we still.
Yeah, thank you. That's lovely. Thank you very much, Paul Laviolette.